Hello everyone, and welcome to my channel. Here, we explore the fascinating world of science, from the mysteries of the universe to the wonders of everyday life. Sit back, relax, and let's discover something amazing together. Science has always been one of humanity's most powerful tools for understanding the world, shaping how we live, think, and perceive reality. From early discoveries such as fire and basic tools to modern achievements like space exploration and genetic engineering, scientific progress has transformed human civilization in remarkable ways. Today, we are able to send spacecraft beyond our solar system, study particles smaller than atoms, and even simulate aspects of human intelligence. These accomplishments may suggest that science is gradually uncovering all the secrets of existence. However, the deeper we explore, the more mysteries we encounter. Despite centuries of research and countless breakthroughs, there remain fundamental questions that science has yet to answer. These are not minor gaps in knowledge, but deep and complex mysteries that challenge our understanding of reality itself. In many ways, modern science is not just about confirming what we know, but about exploring what we still do not understand. These mysteries exist at every level of the universe, from the vastness of space to the inner workings of the human mind, reminding us that knowledge is always incomplete. At the largest scale, scientists continue to question the very existence of the universe. Why does the universe exist at all instead of nothing? What caused it to begin, and what came before it? Even with advanced telescopes and theories, we can only observe a limited portion of the cosmos, leaving much of it unknown. At the smallest scale, the situation becomes equally puzzling. The laws of physics sometimes behave in ways that seem contradictory. Quantum mechanics describes a strange world where particles can exist in multiple states at once, while relativity explains gravity and the structure of space-time. Both theories are highly successful, yet they do not fully agree with each other, suggesting that our understanding of reality is still incomplete. Closer to human experience, life itself remains one of the greatest mysteries. Scientists are still unsure how life first emerged from non-living matter, how the first cells formed, and why biological systems developed the way they did. Even the human body, which has been studied extensively, continues to reveal unexpected complexity. Processes such as aging, disease, and regeneration are not fully understood, and many biological mechanisms remain unclear. Perhaps even more fascinating is the human brain, the organ responsible for thought, memory, and consciousness. Despite decades of research, we still do not fully understand how awareness arises, how memories are stored, or why we experience emotions. In a sense, we are using something we do not completely understand to try to understand everything else. The purpose of this presentation is to explore some of the most significant unsolved mysteries in modern science. Instead of focusing on what is already known, we will examine the questions that remain unanswered and consider why they are so difficult to solve. These mysteries span multiple fields, including physics, astronomy, biology, and psychology, showing both the achievements and the limitations of human knowledge. By exploring these topics, we can better appreciate how far science has come and how much still remains unknown. It is important to recognize that uncertainty is not a weakness of science, but one of its greatest strengths. Science is not a fixed collection of facts, but a continuous process of questioning, testing, and discovery. Every unanswered question creates an opportunity for new ideas and deeper understanding. Throughout history, many mysteries have eventually been solved through better tools and new perspectives. For example, diseases that were once unexplained are now understood through biology, and the movement of planets can now be predicted with precision. In this way, mysteries play a key role in driving scientific progress. At the same time, it is possible that some mysteries may never be fully solved. There may be limits to what humans can understand, whether due to technological constraints or the nature of reality itself. Certain parts of the universe may always remain beyond our observation, and the complexity of the human brain may prevent us from fully understanding consciousness. This raises an important question. Are there aspects of reality that are beyond human comprehension? While science continues to expand our knowledge, it also reminds us of our limitations. As we move forward, this presentation will explore several major categories of scientific mysteries, including the origin of the universe, unexplained physical phenomena, mysteries in astronomy, the origins of life, questions in biology and evolution, the nature of the brain and consciousness, and the complexities of behavior and perception. Each of these areas reveals a different aspect of what we do not yet understand, showing that science is not a finished system, but an ongoing journey. Ultimately, science is not about having all the answers, but about continuing to ask meaningful questions. And as long as questions remain, the pursuit of knowledge will never truly end. When you look up at the night sky, it may feel as though the universe is something distant, something separate from you. But in reality, you are part of it, shaped by the same forces and materials that formed the stars. And yet, despite all that science has revealed about galaxies, planets, and cosmic history, one of the most fundamental questions remains unanswered. Why does the universe exist at all? This question may sound simple, but it is one of the deepest mysteries in science and philosophy. Why is there something instead of nothing? What caused the universe to come into being? These questions push beyond observation and into the limits of human understanding. The most widely accepted scientific explanation for the origin of the universe is the Big Bang Theory. According to this model, the universe began around 13.8 billion years ago from an extremely hot and dense state and has been expanding ever since. Observations such as the cosmic microwave background radiation and the redshift of distant galaxies strongly support this idea. However, while the Big Bang Theory explains how the universe evolved from its earliest known state, it does not fully explain why it happened in the first place. What triggered the Big Bang? Was it truly the beginning, or was it just one event in a much larger process? Some theories suggest that the universe could have emerged from quantum fluctuations, while others propose that it is part of an endless cycle of expansion and contraction. Still, none of these ideas have been definitively proven. Another major mystery is whether the universe is finite or infinite. When scientists observe the cosmos, they are limited by what is known as the observable universe, which is the portion of space from which light has had time to reach us since the Big Bang. Beyond this boundary, there may be much more that we simply cannot see. The universe could extend infinitely in all directions, or it could have a shape and boundary that we are unable to detect. This limitation means that no matter how advanced our technology becomes, there may always be regions of the universe that remain forever hidden from us. Closely related to this is the concept of the multiverse, the idea that our universe may not be the only one. Some theories in physics, particularly those related to cosmic inflation and quantum mechanics, suggest that there could be multiple universes, each with its own set of physical laws and constants. In such a scenario, our universe would be just one of many, possibly one among an infinite number. This idea raises fascinating possibilities. For example, in another universe, the laws of physics might be slightly different, making life as we know it impossible, or perhaps creating entirely different forms of existence. However, the multiverse remains highly speculative, as there is currently no direct evidence to confirm its existence. Another profound question concerns what lies beyond the observable universe. Because light travels at a finite speed, we can only see as far as light has been able to travel since the beginning of the universe. This creates a natural limit to our observations.
Beyond this SEMA, there could be more galaxies, different structures, or even entirely different physical conditions. The problem is that we may never be able to observe or test what exists beyond this SEMA, making it one of the ultimate unknowns in science.
This highlights a key limitation. Some aspects of reality may be fundamentally inaccessible to human investigation. All of these mysteries point to a deeper issue, which is that we may not yet fully understand the nature of reality itself. The universe appears to follow certain laws, but we do not know why these laws exist or why they have the specific values that they do. For instance, if the fundamental constants of physics were even slightly different, the universe might not be able to support stars, planets, or life. This has led some scientists to suggest that our universe appears to be fine-tuned for existence, but whether this is due to chance, necessity, or some deeper principle remains unknown. At this point, science reaches a boundary where empirical evidence becomes difficult to obtain, and theoretical ideas become harder to test. While scientists continue to develop new models and technologies, there is a growing awareness that some questions may require entirely new ways of thinking. The origin of the universe, the possibility of multiple universes, and the limits of observation are not just scientific problems. They are also philosophical challenges that force us to reconsider what it means to understand something. In the end, the mystery of the universe's existence reminds us of both the power and the limits of science. We have made incredible progress in describing how the universe behaves, but the question of why it exists remains open. This does not mean that the question is unimportant. In fact, it may be one of the most important questions we can ask. It drives curiosity, inspires new theories, and encourages us to keep exploring, even when the answers are uncertain. As we continue forward, we move from the largest questions about existence itself to the strange and sometimes counterintuitive laws that govern the universe at a fundamental level, where reality behaves in ways that challenge our intuition and understanding. As we move from the question of why the universe exists to how it actually works, we begin to encounter some of the most puzzling and counterintuitive phenomena in modern physics. At first glance, the physical world appears orderly and predictable, governed by clear laws that scientists can describe with equations. However, when we look more closely, especially at very large or very small scales, this sense of certainty begins to break down. Some of the most fundamental aspects of the universe remain unexplained, and in some cases, even contradictory. One of the most significant mysteries in physics today is the existence of dark matter and dark energy. Together, these two components are believed to make up about 95% of the universe, yet they cannot be directly observed. Dark matter does not emit, absorb, or reflect light, making it invisible to current instruments. Scientists only know it exists because of its gravitational effects, such as the way galaxies rotate and how light bends as it passes through space. Without dark matter, many cosmic structures simply would not behave the way they do. Dark energy, on the other hand, is even more mysterious. It is thought to be responsible for the accelerated expansion of the universe, a discovery that surprised scientists in the late 20th century. Despite its enormous influence, no one fully understands what dark energy is or why it exists. In a sense, most of the universe is made of something we cannot directly detect or explain. Another deeply puzzling concept is the arrow of time. In everyday life, time seems to move in one clear direction, from the past to the future. We remember yesterday, but not tomorrow. We see a glass shatter, but we never see the pieces spontaneously come back together. However, when physicists examine the fundamental laws of nature, they find that many of them are time-symmetric, meaning they do not prefer one direction of time over another. This raises an important question. Why does time appear to flow in only one direction? One possible explanation involves entropy, a measure of disorder, which tends to increase over time. This idea suggests that the arrow of time is connected to the overall tendency of systems to move from order to disorder. Still, this explanation is not complete, and the true nature of time remains uncertain. Closely related to this is the concept of fine-tuning in the universe. The fundamental constants of physics, such as the strength of gravity or the charge of an electron, appear to have very specific values that allow the universe to exist in its current form. If these constants were even slightly different, stars might not form, atoms might not hold together, and life as we know it would not be possible. This has led scientists to wonder whether these values are simply the result of chance, or whether there is some deeper principle that determines them. Some theories, including the idea of a multiverse, suggest that there could be many universes with different constants, and we happen to exist in one that supports life. However, this remains speculative and difficult to test. Perhaps the most famous unresolved problem in physics is the conflict between general relativity and quantum mechanics. General relativity, developed by Albert Einstein, describes gravity and the large-scale structure of the universe with remarkable accuracy. It explains how massive objects curve space and time, and it has been confirmed through numerous experiments and observations. Quantum mechanics, on the other hand, governs the behavior of particles at the smallest scales. It introduces concepts such as probability, uncertainty, and wave-particle duality, which challenge classical intuition. Both theories are extremely successful in their respective domains, yet they are fundamentally incompatible with each other. When scientists try to combine them into a single framework, the mathematics breaks down. This has led to the search for a theory of quantum gravity, which would unify these two pillars of physics, but so far, no complete and experimentally verified solution has been found. At the quantum level, reality itself becomes strange in ways that are difficult to fully comprehend. One example is superposition, the idea that a particle can exist in multiple states at the same time until it is measured. Another is quantum entanglement, where two particles become linked in such a way that the state of one instantly affects the state of the other, regardless of the distance between them. These phenomena have been confirmed through experiments, yet their implications are still debated. They challenge our understanding of causality, locality, and even the nature of reality itself. Some interpretations suggest that observation plays a role in determining outcomes, while others propose that all possible outcomes exist simultaneously in different branches of reality. These unexplained phenomena highlight a key point: the deeper we investigate the universe, the more complex and mysterious it becomes. What once seemed like simple, universal laws now appear to be part of a much more intricate and incomplete picture. While physics has provided powerful tools for describing the world, it has also revealed how much we still do not know. At this stage, science is both confident and uncertain. Confident in its ability to make precise predictions and develop useful technologies, but uncertain about the deeper meaning and origin of the laws it relies on. This balance between knowledge and mystery is what drives continued exploration. Scientists continue to develop new theories, build more advanced experiments, and search for evidence that could resolve these questions. However, it is also possible that some of these mysteries may require entirely new ways of thinking, beyond the frameworks we currently use. As we move forward, we leave behind the abstract laws of physics and turn our attention to the universe as it appears on a larger scale, where massive objects, extreme environments, and cosmic events present their own set of unanswered questions, many of which challenge our ability to observe and understand the cosmos. As we shift from the abstract laws of physics to the vast structures of the cosmos, the universe begins to reveal itself not only as immense, but also deeply mysterious in its behavior. Astronomy and cosmology allow us to observe distant galaxies, powerful cosmic events, and extreme environments that cannot be recreated on Earth. Yet, even with advanced telescopes and sophisticated models, many of the most fascinating phenomena in the universe remain only partially understood. One of the most intriguing and mysterious objects in the universe is the black hole. Formed from the collapse of massive stars, black holes are regions of space where gravity is so strong that nothing, not even light, can escape. According to general relativity, a black hole contains a boundary known as the event horizon, beyond which information cannot return to the outside world. At the center lies what is predicted to be a singularity, a point of infinite density where the known laws of physics break down. While black holes have been observed indirectly through their effects on nearby matter and even imaged in recent years, their true nature remains uncertain. A particularly challenging problem related to black holes is the information paradox. According to quantum mechanics, information cannot be destroyed. However, if something falls into a black hole and is lost beyond the event horizon, it seems that the information about it disappears forever. This creates a contradiction between quantum theory and general relativity. The concept of Hawking radiation, proposed by physicist Stephen Hawking, suggests that black holes can slowly lose mass and eventually evaporate by emitting radiation. While this idea provides a possible way for information to escape, it has not yet been directly observed, and the paradox remains unresolved. This problem is not just about black holes. It represents a deeper conflict in our understanding of the fundamental laws of nature. Another major mystery concerns the formation of the first stars in the universe. After the Big Bang, the universe was initially filled with simple elements like hydrogen and helium. Over time, these elements began to gather under the influence of gravity, eventually forming the first stars. However, the exact process by which these early stars formed is still not fully understood. These first stars, often referred to as population 3 stars, are believed to have been much larger and hotter than stars today, but no direct observations of them have been made. Understanding how they formed is important because they played a key role in shaping the structure of the universe and creating heavier elements necessary for planets and life. Closely related to this is the mystery of supermassive black holes. These enormous black holes, found at the centers of most galaxies, including our own Milky Way, can have masses millions or even billions of times greater than the Sun. What puzzles scientists is how these massive objects formed so quickly in the early universe. Observations show that supermassive black holes already existed when the universe was relatively young, which suggests that they must have grown at an extremely rapid rate. Current theories struggle to fully explain this rapid growth, and new ideas continue to be explored. In addition to these large-scale structures, Astronomers have also detected mysterious signals from deep space that remain unexplained. One example is fast radio bursts, which are extremely short and powerful bursts of radio waves originating from distant galaxies. These bursts last only a fraction of a second, yet they can release as much energy as the Sun emits over several days. While some fast radio bursts have been linked to highly magnetized neutron stars known as magnetars, not all observations fit this explanation, and their exact origins are still debated. The unpredictable nature of these signals makes them difficult to study, adding to the mystery. Another challenge in astronomy is the limitation of observation itself. The universe is vast, and light takes time to travel across it. This means that when we observe distant objects, we are actually looking back in time. While this allows us to study the early universe, it also means that there are limits to what we can see. Some regions may be too far away, too faint, or hidden behind cosmic dust, making them inaccessible to current technology. As a result, our understanding of the universe is based on incomplete information, and there may be phenomena that we have not yet detected. These mysteries highlight the complexity of the universe and the challenges of studying it. Astronomy and cosmology rely heavily on observation, but when dealing with extreme distances and conditions, direct experimentation is often impossible. Scientists must interpret signals, develop models, and test theories using limited data, which can lead to uncertainty and debate. However, this also makes the field dynamic and exciting, as new discoveries can quickly change our understanding. Ultimately, the study of the universe reveals both how much we have learned and how much remains unknown. From the nature of black holes to the origins of cosmic structures and mysterious signals from deep space, each unanswered question points to deeper layers of complexity. These mysteries not only challenge existing theories but also inspire new ideas and technologies. As we continue this journey, we move from the vastness of the cosmos to something closer to our own existence, exploring one of the most fundamental questions of all: how life itself began, and what it truly means to be alive. As we move from the vastness of the universe to something far more familiar, we arrive at one of the most profound and personal mysteries in science: the origin of life. While we have learned a great deal about living organisms, their structures, and their functions, the question of how life first emerged from non-living matter remains largely unanswered. This mystery lies at the intersection of biology, chemistry, and physics, and it challenges our understanding of what it truly means to be alive. The early Earth, more than 3 billion years ago, was a very different place from the world we know today. It was a harsh and unstable environment, with high temperatures, volcanic activity, and a chemically rich atmosphere. Yet, somehow, within this environment, simple molecules began to organize into more complex structures, eventually leading to the first living cells. Scientists have proposed several hypotheses to explain this process, but none have been fully confirmed. One of the most widely discussed ideas is the concept of abiogenesis, which suggests that life arose naturally from non-living chemical substances. According to this theory, simple organic molecules formed first, possibly in environments such as shallow pools, deep-sea hydrothermal vents, or even through chemical reactions in the atmosphere. Over time, these molecules may have combined to form more complex compounds, such as proteins and nucleic acids. Eventually, these systems may have developed the ability to replicate themselves, a key characteristic of life. While laboratory experiments have shown that some of these steps are possible under controlled conditions, the full pathway from non-living matter to living cells has not yet been recreated. A central question in this process is the origin of the first cell. Modern cells are incredibly complex, containing structures such as membranes, genetic material, and molecular machinery for energy and reproduction. It is difficult to imagine how such complexity could arise spontaneously. One idea is the RNA world hypothesis, which proposes that early life may have been based on RNA molecules that could both store information and catalyze chemical reactions. This would simplify the problem, as it suggests a stage of life before the development of DNA and proteins. However, there are still many unanswered questions about how RNA itself could have formed and stabilized under early Earth conditions. Another important aspect of life is the structure of DNA, the molecule that carries genetic information in all known living organisms. DNA has a very specific and efficient structure, allowing it to store vast amounts of information and replicate with high accuracy. Scientists still debate why DNA evolved into its current form and whether alternative genetic systems could exist. This question becomes especially important when considering the possibility of life beyond Earth. If life exists elsewhere in the universe, it may not necessarily be based on DNA or follow the same biochemical rules as life on Earth. The origin of viruses presents another layer of mystery. Viruses are unique because they exist at the boundary between living and non-living systems. They cannot reproduce on their own and must rely on host cells, yet they contain genetic material and evolve over time. Scientists are still debating where viruses came from. Some theories suggest that they originated from fragments of genetic material that escaped from cells, while others propose that they may be remnants of ancient life forms that have simplified over time. Understanding viruses is important not only for biology, but also for understanding the early stages of life itself. Beyond Earth, the question of whether life exists elsewhere in the universe remains open. Given the vast number of planets and stars, it seems possible that life could have developed in other environments. Scientists have discovered many exoplanets that exist in what is known as the habitable zone, where conditions might allow for liquid water, a key ingredient for life as we know it. However, despite extensive searches, there is still no direct evidence of extraterrestrial life. This leads to an interesting paradox. If the universe is so large and potentially hospitable, why have we not found clear signs of life beyond Earth? This question, often referred to as the Fermi paradox, highlights the gap between expectation and observation. All of these questions point to a deeper issue, which is the definition of life itself. While we can describe the characteristics of living systems, such as metabolism, growth, and reproduction, there is no single, universally accepted definition of life. This makes it even more difficult to determine how life began and how it might exist in different forms. It also raises philosophical questions about what distinguishes living systems from non-living ones. The mystery of life's origin reminds us that even the most familiar aspects of existence are not fully understood. Life surrounds us, and we are part of it, yet its beginnings remain hidden in the distant past. Scientists continue to investigate this question through experiments, observations, and theoretical models, but the answer may require new discoveries and new ways of thinking. As we continue this exploration, we move from the origin of life to the ongoing processes that shape it, including evolution, aging, and the remarkable diversity of living organisms, many of which challenge our current understanding of biology. As we move beyond the origin of life and look at how life develops and changes over time, we enter the field of biology and evolution, where many processes are well understood, yet still filled with unanswered questions. Evolution by natural selection explains how species adapt to their environments and how complex organisms arise from simpler ones. However, even within this powerful framework, there remain deep mysteries about how life functions, how it ages, and how certain organisms achieve abilities that seem almost extraordinary. One of the most universal yet least understood aspects of life is aging. Every living organism, from simple cells to complex humans, experiences some form of aging, a gradual decline in biological function over time. Scientists have identified several contributing factors, such as the accumulation of cellular damage, the shortening of telomeres, and the gradual breakdown of molecular systems. However, no single explanation fully accounts for why aging occurs or why it happens at different rates in different species. Some organisms age rapidly, while others can live for decades or even centuries with minimal signs of decline. This raises an important question. Is aging an unavoidable consequence of life, or could it potentially be slowed down or even reversed? Closely related to aging is the question of the limits of human lifespan. While advances in medicine, nutrition, and technology have significantly increased average life expectancy, there appears to be a natural limit to how long humans can live. Most scientists estimate that this limit lies somewhere around 120 years, based on current biological constraints. However, there is ongoing debate about whether this limit is fixed or if future discoveries could extend it further. Research into genetics, stem cells, and cellular repair mechanisms suggests that it may be possible to delay some aspects of aging, but completely overcoming biological limits remains uncertain. Another fascinating mystery in biology is the ability of some organisms to regenerate lost body parts. Certain species, such as salamanders and starfish, can regrow limbs, organs, and even parts of their nervous systems. This level of regeneration is far beyond what humans are capable of. While scientists have identified some of the genetic and cellular mechanisms involved, they do not fully understand why such abilities exist in some species but not in others. If these mechanisms could be understood and applied to human biology, they could revolutionize medicine, particularly in the treatment of injuries and degenerative diseases. There are also organisms that challenge our understanding of disease and survival. For example, some species appear to have an extraordinary resistance to cancer. The naked mole rat, for instance, has unique biological mechanisms that prevent uncontrolled cell growth, making cancer extremely rare in this species. Similarly, large animals like elephants have additional copies of certain genes that help suppress tumors. These examples raise important questions about why cancer is so common in humans, despite the fact that evolution should favor mechanisms that protect against it. Understanding these differences could provide valuable insights into disease prevention and treatment. Another area of uncertainty lies in the complexity of evolution itself. While natural selection explains how traits that improve survival and reproduction become more common, it does not always explain the emergence of highly complex structures. Features such as the human brain, the eye, or the intricate behaviors seen in some animals appear to require multiple coordinated changes, which can be difficult to account for step by step. Scientists continue to study how such complexity evolves, considering factors such as genetic variation, environmental pressures, and random mutations. However, the exact pathways leading to certain biological innovations are still not fully understood. In addition, evolution does not always follow a straightforward or predictable path. Some species remain relatively unchanged for millions of years, while others evolve rapidly in response to environmental changes. This variation raises questions about what drives evolutionary rates and why certain species are more adaptable than others. It also highlights the role of chance in evolution, where random events can have significant long-term effects on the development of life. These mysteries show that biology is not just a collection of established facts, but a dynamic field full of ongoing questions. Even though we have mapped genomes, studied cells in detail, and developed advanced medical technologies, the fundamental processes that govern life are still not completely understood. The study of aging, regeneration, disease resistance, and evolution continues to reveal new complexities and challenges. At the same time, these unanswered questions provide opportunities for discovery. By studying organisms with unusual abilities, scientists can gain insights that may lead to new medical treatments and a deeper understanding of life itself. Advances in biotechnology, genetics, and computational modeling are helping researchers explore these questions in ways that were not possible before. Ultimately, the mysteries of biology and evolution remind us that life is both fragile and remarkably resilient. It adapts, changes, and persists in ways that often surprise us. While we have made great progress in understanding how life works, there is still much to learn about why it works the way it does. As we continue, we shift our focus from the biological processes that shape life to the inner world of the human mind, exploring one of the most complex and least understood systems in existence, the brain and the nature of consciousness. As we move from the biological processes of life to the inner workings of the human mind, we arrive at one of the most complex and least understood areas of science, the brain and consciousness. The brain is often described as the most sophisticated structure in the known universe, containing billions of neurons connected through trillions of synapses. It controls everything we do, from basic bodily functions to complex thoughts, emotions, and decisions. Yet, despite decades of research in neuroscience, we still do not fully understand how the brain gives rise to consciousness, the subjective experience of being aware. One of the most fundamental questions is how consciousness itself emerges. We know that specific regions of the brain are associated with certain functions, such as vision, memory, or language. Brain imaging technologies can even show patterns of activity that correspond to different thoughts or emotions. However, this does not explain why these processes are accompanied by subjective experience. In other words, why does brain activity feel like something from the inside? This problem is often referred to as the hard problem of consciousness, and it remains one of the greatest challenges in both science and philosophy. Closely related to consciousness is the mystery of dreams. Every night, as we sleep, the brain generates vivid experiences that can feel as real as waking life. Dreams can be emotional, confusing, or even creative, yet their purpose is still not fully understood. Some scientists suggest that dreams help process memories, organize information, or regulate emotions. Others propose that they are simply a byproduct of brain activity during sleep. While research has provided insights into the stages of sleep and the neural mechanisms involved, the deeper meaning and function of dreams remain uncertain. Memory is another area filled with unanswered questions. We rely on memory to learn, make decisions, and form our sense of identity. Yet we do not fully understand how memories are stored and retrieved. It is known that memories are distributed across networks of neurons, and that they can change over time. In fact, each time we recall a memory, it may be altered slightly before being stored again. This means that memory is not a perfect record of the past, but a dynamic and reconstructive process. Scientists are still investigating how memories are encoded at the molecular level and how they are maintained over long periods. Our perception of time also reveals the complexity of the brain. Physically, time is measured in consistent units, but psychologically, it can feel very different. Moments of excitement may seem to pass quickly, while periods of boredom can feel much longer. This subjective experience of time suggests that the brain actively constructs our sense of duration, rather than simply recording it. The mechanisms behind this process are not fully understood, and they highlight the gap between objective reality and human perception. Emotions, creativity, and unusual experiences such as déjà vu further illustrate how little we know about the brain. Emotions play a crucial role in decision-making and social interaction, yet their origins and regulation are only partially understood. Creativity, the ability to generate new and original ideas, is even more difficult to explain. It involves the interaction of multiple brain regions and processes, but there is no single explanation for how creative insights arise. Déjà vu, the feeling that a current situation has been experienced before, is another phenomenon that lacks a clear explanation, though it may be related to memory processing errors. These mysteries highlight an important point. The brain is not just a biological organ, but the foundation of our experience of reality. Everything we perceive, think, and feel is shaped by its activity. Yet, we are still far from understanding how it produces such a rich and complex inner world. This creates a unique challenge, because studying the brain means using the brain itself as a tool, which may introduce limitations in how much we can truly understand. At the same time, advances in neuroscience and technology are providing new opportunities to explore these questions. Techniques such as brain imaging, neural recording, and artificial intelligence are helping scientists uncover patterns and relationships that were previously hidden. However, even with these tools, the deeper nature of consciousness and subjective experience remains elusive. The study of the brain and consciousness forces us to confront some of the most fundamental questions about what it means to be human. Are our thoughts and decisions fully determined by physical processes? Or is there something more? Can consciousness be explained entirely in scientific terms? Or does it require new concepts and frameworks? These questions do not have simple answers, but they continue to inspire research and debate. As we move forward, we turn from the inner workings of the mind to the ways in which behavior and perception shape our interactions with the world, revealing that even everyday experiences can hide deep and unexpected mysteries. As we move from the inner workings of the brain to how we interact with the world around us, we begin to explore the mysteries of behavior and perception. These are aspects of everyday life that feel familiar and natural, yet they are shaped by complex processes that we do not fully understand. From the way we respond to treatment, to how we sleep, communicate, and form emotions, many common human experiences still contain deep scientific questions. One of the most fascinating examples is the placebo effect. This occurs when a person experiences real physical or psychological improvement after receiving a treatment that has no active medical ingredient, such as a sugar pill. The effect is not imaginary. Measurable changes can occur in the body, including reduced pain or improved mood. This suggests that belief and expectation can influence biological processes in powerful ways. However, scientists still do not fully understand how the brain translates expectation into physical change, or why the placebo effect varies so much between individuals. It challenges the traditional idea that only chemical or physical treatments can produce real medical outcomes. Another essential but still mysterious aspect of human life is sleep. Every person spends about 1/3 of their life sleeping, yet the full purpose of sleep is not completely understood. It is known that sleep is important for memory, learning, and physical health. During sleep, the brain undergoes different stages, including rapid eye movement, REM, sleep, which is often associated with dreaming. However, why sleep is absolutely necessary, and why it evolved in the first place, are still open questions. From an evolutionary perspective, sleep seems risky, as it leaves an organism vulnerable to danger. Despite this, it is nearly universal among animals, suggesting that its benefits are fundamental and irreplaceable. Human behavior also includes complex forms of communication and expression, such as language, laughter, and music. The origin of language, in particular, remains one of the most intriguing mysteries. Language allows humans to share ideas, build cultures, and pass knowledge across generations. While scientists have identified brain regions involved in language processing, they do not fully understand how language first developed or why only humans have such advanced linguistic abilities. Similarly, laughter appears to be a social behavior that strengthens relationships and reduces tension, yet its exact evolutionary purpose is still debated. Music is another unique aspect of human culture that is difficult to explain scientifically. People across all cultures create and respond to music, often experiencing strong emotional reactions. However, music does not have a clear survival function in the same way as food or shelter. Some theories suggest that it evolved as a form of social bonding or communication, while others see it as a byproduct of other cognitive abilities. Regardless of its origin, the universal presence of music highlights the complexity of human perception and emotion. Love and emotional attachment are also deeply important, yet not fully understood. These experiences involve both biological processes, such as hormones and neural activity, and psychological and social factors. Love can influence behavior, decision-making, and well-being in profound ways. While scientists can study the chemical changes associated with emotional attachment, the subjective experience of love remains difficult to define or explain completely. It represents a connection between biology and personal experience that is still being explored. Beyond humans, the behavior of animals also presents fascinating mysteries. Many species demonstrate abilities that seem surprisingly advanced. For example, some birds and marine animals can navigate across vast distances with remarkable accuracy, even without visible landmarks. The mechanisms behind this ability may involve sensitivity to Earth's magnetic field or other environmental cues, but the exact processes are not fully understood. These examples show that complex behavior is not limited to humans and that many animals possess capabilities that challenge our assumptions. Perception itself, the way we interpret sensory information, is another area filled with uncertainty. What we see, hear, and feel is not a direct representation of reality, but a construction created by the brain. This means that our experience of the world can be influenced by expectations, context, and prior knowledge. Optical illusions, for example, demonstrate how perception can differ from physical reality. This raises an important question: to what extent can we trust our senses? If perception is shaped by the brain, then our understanding of the world is always filtered and potentially limited. These everyday phenomena reveal that even the most familiar aspects of life are deeply complex. Behavior and perception are shaped by interactions between biology, environment, and experience, making them difficult to study in isolation. While significant progress has been made in psychology and neuroscience, many questions remain unanswered. At the same time, these mysteries highlight the richness of human experience. They show that science is not only about distant galaxies or abstract theories, but also about understanding ourselves and how we relate to the world. By studying behavior and perception, scientists hope to gain insights that can improve health, communication, and overall well-being. As we reach the end of the main content, we begin to reflect on what these mysteries mean as a whole. From the vast universe to the human mind, each unanswered question reminds us that science is not complete, but an ongoing journey driven by curiosity and the desire to understand. As we come to the end of this exploration, it becomes clear that science, despite its incredible achievements, is still far from complete. Throughout this presentation, we have examined some of the most profound and challenging mysteries across multiple fields, from the origins of the universe to the complexities of human thought and behavior. Each topic has revealed a different layer of uncertainty, showing that even our most advanced knowledge is only a partial understanding of reality. We began with the largest questions about existence itself, asking why the universe exists and how it began. While the Big Bang Theory provides a strong explanation for the early development of the universe, it does not answer what caused it or what came before. We then explored the strange and often counterintuitive world of physics, where concepts like dark matter, dark energy, and quantum phenomena challenge our basic assumptions about how reality works. These ideas show that much of the universe operates according to principles that are still not fully understood. Moving into astronomy and cosmology, we encountered objects and events that push the limits of observation, such as black holes, the formation of the first stars, and mysterious signals from deep space. These phenomena remind us that even with powerful technology, there are still boundaries to what we can observe and explain. Beyond that, we examined the origin of life, one of the most fundamental questions of all. Despite advances in biology and chemistry, the exact process by which life emerged from non-living matter remains uncertain, and the possibility of life beyond Earth continues to raise new questions. In the study of biology and evolution, we saw that even well-established theories leave room for mystery. Aging, regeneration, disease resistance, and the complexity of living systems all present challenges that scientists are still working to understand. These questions are not only theoretical, but also have practical implications for health and medicine. We then turned inward to the human brain and consciousness, where the challenge becomes even more profound. The fact that we do not fully understand how awareness arises, or how thoughts and emotions are created, highlights the limits of current scientific knowledge. Finally, we explored behavior and perception, showing that even everyday experiences such as sleep, language, emotion, and belief are more complex than they appear. The placebo effect, the purpose of sleep, and the origins of communication all demonstrate that human behavior is influenced by factors that are not yet fully explained. These mysteries bring science closer to our daily lives, reminding us that the unknown is not only found in distant galaxies, but also within ourselves. Taken together, these topics reveal a central idea. Science is not a finished system of knowledge, but an ongoing process of discovery. Each answer leads to new questions, and each discovery uncovers new areas of uncertainty. This is not a limitation, but a strength. The presence of unanswered questions is what drives scientific progress, encouraging curiosity, creativity, and critical thinking. Without mysteries, there would be no reason to explore further. At the same time, these mysteries also remind us of our limitations. There may be aspects of reality that we are not yet able to understand, or perhaps may never fully comprehend. Whether due to technological constraints, the complexity of nature, or the limits of human cognition, some questions may remain open for a very long time. This does not reduce the value of science, but instead adds a sense of humility to our pursuit of knowledge. In the end, science is not about reaching a final destination where everything is known. It is about the journey of exploration, the process of asking questions, testing ideas, and gradually expanding our understanding of the world. The mysteries we have discussed are not obstacles, but opportunities. Opportunities to learn more, to think differently, and to continue pushing the boundaries of what is possible. As we conclude, the most important message to take away is this: the unknown is not something to fear, but something to explore. The fact that so many questions remain unanswered means that there is still much to discover, and that the future of science is full of potential. Whether it is understanding the universe, unlocking the secrets of life, or exploring the depths of the human mind, the search for knowledge will continue. And as long as curiosity exists, science will never truly come to an end. To conclude the presentation, here are a few short questions to encourage discussion and deeper thinking. Which mystery do you think is the most important or most interesting, and why? Do you believe humans will eventually be able to explain everything in the universe, or are there limits to our understanding? And finally, when facing these big questions, do you think science alone is enough, or do we also need philosophy to help us find answers?